let's look at a hypothesis test where we'll apply the central limit theorem. So here we have a Nielsen survey, sample size 340 US middle school students about whether they prefer a self-driving car or a car they drive themselves. Majority, interesting, majority, 59% said that they would prefer a car that can control themselves, that they control themselves. 41% prefer a self-driving car. We're going to use a 5% significance level to see if this is evidence that more than 50%. So generally, a majority is more than 50%. 59 is more than 50%. Given this sample size, is it significantly more? To answer that question, whether it's significantly more, we need a hypothesis test. So first, we'll set up our hypotheses. So again, looking at this last statement, we want to see if the evidence is that more than 50% of middle school students prefer a car they can control themselves. So that would be our null hypothesis. That the proportion of middle school students who prefer a car they can control themselves, we're going to check to see if it is equal to 50% versus the alternative stated above, that proportion is greater than 50%. And again, what is P here? P is the proportion of middle school students who prefer to control the car themselves. All right, and then we're told to use a significance level alpha of 5%. So then we need to compare that to the sample statistics. So what does the sample tell us here? As far as the sample goes, our statistics are the sample size of 340. And then we have also P hat of 59% said they'd prefer to control the car themselves. All right. To use the central limit theorem here, we should first check to see that this meets the conditions of the central limit theorem. So the conditions of the central limit theorem is that the favorable count is greater than 10 and the unfavorable count is greater than 10. So the favorable count would be the number of students who said, I prefer to drive the car myself, and then the unfavorable would be the rest of them. So let's check that on the calculator just to make sure they're both greater than 10. And based on the sample size, I think we're going to be okay here. So we've got 59% of 340 students, which is about 200 of them said, I prefer to drive myself. And then the rest of them, so that'd be 1 minus the 59%, 41%. And actually the math's pretty straightforward. I guess it's more like 201, right? Would be the rest of them. And 340 minus 201 is definitely greater than 10. So we can just double check that. 41% of 340, right? That's the other 139 students. So those, both the favorable and the not favorable, are greater than 10. So we're good. We can apply the central limit theorem. What does it mean to apply the central limit theorem? It means that we're going to calculate a z-score and then use that z-score to find the probability. So the z-score is always going to be p hat minus p divided by the standard error. And according to the central limit theorem, the standard error is going to be p times 1 minus p over n. So in this problem, we're going to get our p hat, which is our 59%, minus our null hypothesis, which states 50%. And then we use the null hypothesis to set up the standard error. So the standard error here is going to be 50%. 1 minus 0.5 is another 0.5. And then divide by the sample size, 340. So that's going to be our z-score. And then we'll have to use a special normal distribution calculator to find the p-value. So next, we've got our fraction. And in our fraction, we have our sample statistic, 0.59, minus our null hypothesis value, 0.5, divided by the square root of the fraction, the null hypothesis value, times 1 minus that, which happens to be the same number, divided by the sample size. All right, so I'm getting a z-score of 3.319-ish. All right, so next thing I need to do is figure out what the p-value is. Now, we already know the 95% rule. So the 95% rule had told us that 95% of the data is going to be within 2 standard deviations of the mean. Right, so that'd be a -2 there and a +2 there. Our z-score is bigger than 3. So 3 is about there. 3.3 is going to be about here. So that's our z-score right there, 3.319. So if there's 95% in the middle with the 2 standard deviation rule that we learned way back when, that means there's 5% for the tails. So 2.5% would be in the right tail. That's coming from 2 standard deviations. So this is going to be way less than that. So we should be getting a pretty tiny p-value out here. So let's look at a normal distribution calculator to figure that out. StatKey has one of those. Theoretical, normal. And for z-scores, we want the mean to be 0 and the standard deviation to be 1. And this here, double check, is a right tail test because of the greater than on the alternative. Alternative always determines the test. And then we enter our z-score. So 3.3, what was it again? 319. So in this case, I got a p-value of 0.00045, pretty little. So that's how we calculate the p-value. A spreadsheet can do this also. I've shared with you a spreadsheet. I'll put that in the description of this video. So if you want to use the spreadsheet instead, it'll give you a similar p-value. And anytime the p-value is less than the significance level, then we are going to reject the null, which means the data supports the alternative, right? So that's the decision, the conclusion. So again, decision, reject null, conclusion is where we write a sentence or so that supports the alternative, right? So in other words, we have sufficient evidence and then what you want to do is state the alternative in words. In words, what does that mean? So fill in the blank there. Important part of this video was we're using the central limit theorem instead of a randomization here. Now we could use a randomization. It's going to give a similar p-value, which omits the z-score. But central limit theorem says we can use a z-score given a sufficiently large sample size, which we checked. And this is the p-value according to the central limit theorem. And again, you have to use a normal distribution calculator, which could be StatKey, some other normal distribution calculator, or a spreadsheet to find the p-value in a situation like this. Thanks for playing.